For a three-phase 208 volt Y electrical system, a standard color code is employed in accordance with the National Electrical Code and established industry practices. The purpose of this color code is to ensure clear identification of the different phase conductors, the neutral conductor, and the ground conductor within the electrical system. This standardization promotes safety, simplifies troubleshooting, and facilitates consistent wiring practices across installations. Firstly, phase A is designated with the color black. The black wire represents one of the three hot conductors in the three-phase system. It carries alternating current and is electrically live when the system is energized. Secondly, phase B is designated with the color red. The red wire represents another one of the three hot conductors in the three-phase system, also carrying alternating current and being electrically live when energized. Thirdly, phase C is designated with the color blue. The blue wire represents the third hot conductor in the three-phase system, completing the set of live conductors. These phase conductors, black, red, and blue, are typically insulated with a thermoplastic high heat-resistant nylon covering rated for 600 volts. The insulation provides electrical isolation and protection against physical damage. Fourthly, the neutral conductor is designated with the color white. The white wire serves as the neutral return path for the unbalanced current in the three-phase system. In a Y configuration, the neutral point is the common connection point of the three-phase windings. The neutral conductor is typically grounded at the service entrance, providing a reference point for the system voltage and facilitating the clearing of ground faults. Fifthly, the ground conductor is designated with the color green or green with a yellow stripe. The green wire serves as the equipment grounding conductor, providing a low impedance path for fault current to return to the source in the event of an electrical fault. The ground conductor is connected to the metal enclosures of electrical equipment, conduit, and other conductive surfaces, ensuring that these surfaces are ground potential. This minimizes the risk of electric shock and provides a path for fault current to flow, tripping a circuit breaker or fuse and de-energizing the circuit. It is important to acknowledge that while this color code is considered the standard, variations may exist, particularly in older installations. The National Electrical Code outlines specific requirements for wire identification and color coding in Article 200.6 and Article 210.5. These sections provide detailed guidelines for marking conductors and ensuring proper identification of different circuit types. In addition, local electrical codes or project specifications may dictate alternative color coding schemes or require additional markings to further differentiate conductors. For example, in some industrial facilities, different colors may be used to distinguish between control circuits, instrumentation circuits, and power circuits. Similarly, in healthcare facilities, specific color codes may be required to identify emergency power circuits and critical life support systems. Because of these potential variations, it is imperative to verify the actual colors of the wires before making any electrical connections. This can be done by visually inspecting the conductors and comparing them to the wiring diagrams or electrical schematics for the system. If the color coding is unclear or uncertain, it is recommended to use a voltage tester or multimeter to identify the different conductors and verify their voltage levels. When working with electrical systems, it is crucial to follow safe work practices and wear appropriate personal protective equipment. This includes wearing insulated gloves, safety glasses, and arc-rated clothing. Before starting any electrical work, always energize the circuit by turning off the appropriate circuit breaker or fuse. Use a voltage tester to verify that the circuit is de-energized before touching any wires or equipment. Furthermore, it is important to understand the specific requirements and regulations that apply to electrical work in the jurisdiction where the work is being performed. This may include obtaining permits, complying with local electrical codes, and following industry best practices. Failure to comply with these requirements can result in fines, penalties, and potentially dangerous electrical hazards. In addition to the basic color code for three-phase 208 volts Y systems, there are other color coding conventions that may be used for specific applications. For example, in control circuits, Different colors may be used to identify different types of signals, such as start, stop, and interlock signals. Similarly, in data communication circuits, different colors may be used to identify different types of data cables, such as Ethernet cables, serial cables, and fiber optic cables. It is also important to note that the color coding of conductors may vary depending on the voltage level of the system. For example, in high voltage systems, different colors may be used to identify different voltage phases, such as phase A, phase B, and phase C. These voltage phase color codes are often specific to the utility company or the power distribution system owner. The National Electrical Code provides detailed requirements for conductor identification and color coding in various sections, including Article 200, Article 210, and Article 310. These sections cover a wide range of topics, such as the identification of grounded conductors, the identification of equipment grounding conductors, and the ampacity of conductors. When working with electrical systems, it is important to consult these sections of the National Electrical Code to ensure that the wiring is installed in accordance with the applicable requirements. In summary, the standard color code for a 3-phase 208-volt wire electrical system is as follows: phase A is black, phase B is red, phase C is blue, neutral is white, and ground is green or green with a yellow stripe. While this color code is widely used, variations may exist, particularly in older installations. Therefore, it is always best to verify the actual colors of the wires before making any electrical connections. By following safe work practices, wearing appropriate personal protective equipment, and complying with the applicable codes and regulations, electrical work can be performed safely and effectively.